Okay guys, here we go. This is video 2 for U6L3. We're going to look at these two examples, alright? So the way I like to start these, and it's going to be maybe a little bit over the top with this first one, but I like to list out 4 characteristics of the graph, okay? Down here, we have a general form for a trig equation, right, or for a sine graph. So A sine B outside the parentheses, so this has been factored out, x minus c and then plus d. If you have the equation in this form, okay, then the period is 2 pi over b. This is the original period. We know, or we should know, that multiplying x by b actually compresses the graph, right, by a factor of b. So whatever b is, the new period will be the original period over b. All right, so if I write that out, let's say that the period is going to equal 2 pi. In this case, b is 2. So 2 pi over 2 is pi. So this is going to compress the graph. The graph would normally take 2 pi units to repeat. Now it's only going to take pi units, and we should know that because we know that multiplying x by 2 creates a horizontal compression. All right, so let me erase this, and then I want to list 3 more characteristics of this graph, and then I'm gonna make it. So the second characteristic, I want to know the amplitude, right? So how high or low this thing goes. In that case, that's just 1. Okay, this a value, this is a vertical stretch or compression, so it's going to control your amplitude, right? So we don't have anything outside multiplying the whole function. Well, we really have a 1, right? So the amplitude is just, it's just 1. We don't have a minus c, we don't have a plus d. So what those do, just for the next one, I call this minus c a phase shift. Okay, so it's going to be movement right or left, but the way I think about it is that's going to be where I start making the graph, okay, whatever the minus c is. So this b, as we said before, affects period, and this d, this affects, it's a shift up or down. It affects the center line of the graph, okay? And I want to be clear, this value right here, b is not the new period, right? We have that formula over here. The period's equal to 2 pi over whatever b is, okay? So don't get confused with that. Maybe I'll do this to make it less confusing. I'll say it affects the period. So in our graph, really we've only got one thing that's changing, right? We've only got one transformation here, it's the 2. So the amplitude is still 1. The period has been changed, it's pi. The phase shift, so basically where I start the graph is 0, right? That it hasn't moved right or left. And the center line, the graph hasn't been moved up or down. Center line, it's also 0. Okay, so just to show you what I mean, and this is going to be pretty ugly, so apologies for that, guys, but that's the center line, and this is the phase shift. That's how I do it. Okay, now I'm making these solid because I know that these haven't been affected. In the next example, we'll look at maybe how to do that when there is a different phase shift, there is a different center line. Okay, so this is x equals 0. This is y equals 0. Gotta erase this. I wrote off the page there. That's not good. Okay, let's make this a little bit smaller. I want to see everything. And it's bothering me that I'm not connecting that. All right, there we go. So let's pick a color, maybe green. And I'm going to make my scale 1, 2, 3, 4, 1, 2, 3, 4. So on the y-axis, 4 blocks represent 1 unit. And I'm just going to do 2 blocks here. No, you know what? Let's redo that. I want to make it a little bit more spread out. I'm going to do 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Hopefully I made 4 groups of 4. Each of these is going to represent pi over 2. Okay, so this is pi. This is 3 pi over 2. And this is 2 pi. So I'm going to make one graph going to the, or one part of the graph, excuse me, going to the right. One full cycle. A cycle means the graph's gone through one rotation, one full period. Okay, and I'm going to make one going to the left. So for me, if you do one full cycle to the right, one full cycle to the left of wherever your phase shift is, that's good enough. So now I just need to 1, 2, 3, 1, 2, 3, 4. I need to count out these negative ones. Shouldn't be that hard to count, Jeff. 1, 2, 3, 4. All right, so it's negative 2 pi. This is negative 3 pi over 2. This is negative pi. And this is negative pi over 2. Okay. Now I just graph my important points. Or plot them, I should say. And then I got the graph. So we know sine starts at the center line. It starts by going up. Okay, and now I can roughly, that's actually not too bad, and then I just jinxed it. So there's one part of the graph. If I fill in these other parts, yeah, good. You know, we kind of want you guys to have the right shape. So every year, you know, there's somebody who does this, right? I don't want to do the whole thing, but I always get a student that does this. All right, no straight lines, guys. That's not good. So we want to see the curvature. So there's the graph of y equals sine 2x. Let's go on to the next one. Okay, so this one, got a lot more going on, right? We've got, this is going to affect, this is going to be a vertical stretch. This is going to be a horizontal stretch or compression. This is going to affect the phase shift. This is going to be a center line. So what I want to do first is write out those characteristics. All right, so the amplitude is, in this case, 3. How am I getting that? Well, it's because it's that vertical stretch. The period is equal to 2 pi over 6. So that's actually 12. Wow. So this thing is going to take 12 units to repeat. Okay? Let's get rid of this too. The phase shift, called PS, it's going to be x equals 4. Let's make that an arrow. Right, so this minus 4 moves the whole graph to the right 4 units. And the center line is going to be negative 1 because this minus 1 is moving the graph down 1 unit. Okay, so the center line is y equals negative 1. Okay, so other teachers might not like this, but if you're one of my guys, I'm fine with it. I'm assuming they'll be okay with it too. But you know, this is an honors class. If we give you a graph that has defined x and y values on the axes, we expect you to adjust. But if you're allowed to freehand it, then here's how I recommend that you do it. So that is supposed to be, let's redo that. That's supposed to be the center line. Okay, and actually what I'll do, I'm going to draw it dotted. Number 1, to make it easier for me to draw a straight line, and number 2, because if I have a chance to actually put in the axes, then I want to do it. So this is y equals negative 1. And then the phase shift is going to be 4. And I like to make the the starting point right in the center of whatever graph I'm given. Okay. So this is x equals 4. What next? Well, the period's 12. So what that tells me is if I go 12 to the right, I'll get 1 cycle. If I go 12 to the left, I'll get 1 cycle. So the way I'm going to do that is I'm going to let let's do 4 again. 1, 2, 3, 4. And let's do another color. Let's do a different color so it's a little bit clearer. 1, 2, 3, 4. So if the whole period's 12, that means each one of these is 3, right? So my scale is not too good. That's not too smart. But if I take 4 plus 12, I get 16, right? And then here's what's cool. Now, because of the symmetry, I know that this value right here is going to be halfway between 4 and 16. So that's going to be at 10. Okay. This value is going to be halfway between 10 and 4, which is 7. And this value here is going to be halfway between 10 and 16. That's going to be 13. Okay? Another way you could do it is just say, well, 12 divided by 4 is 3, so every increment is 3 units. All right? Either way. And again, this isn't too smart. I have 4 blocks representing 3 units, but all we really care about is the numbers, right? Going the other way, so 1, 2, 3, this is kind of comical. So this is going to be 1, this is going to be -2, that's going to be -5, that's going to be -8, and if I've done this correctly, halfway between -8 and 16 should be 4. Yeah, so we're good with that. Same idea with amplitude. So the amplitude is 3, so what that means is that we're going to go up and down 3 units. Okay? So I'm actually going to make it a little bit more to scale. So if I go up 3 units from -1, this is 2, and this is -4, right? That's 3 units down from -1. Okay, now let's fill in the graph. I'm going to use gray here. So this is a sine graph, starts there. There's no reflection, so kind of know the shape. It's going to look something like that. And what's cool about this too is now you don't really need to plot any points, right? If I'm looking at that point, I know the coordinates of that are 13, -4. If I'm looking at this point, I know the coordinates of it are 10, -1. Okay, if you have the time and you can label the points, great. But it depends on what you're asked to do. Let's fill in the rest of this. So we got here, 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 here. Fill that guy in, make that continued. Okay, so we're picking strategic points. We're picking points that are either on the center line, right? 1, 2, 3, 4, 5 center line points, or we're picking maxes, or we're picking mins. One other thing, I mentioned that these values, the phase shift and center line, I dotted them because I wanted to see if I can plot the axes. Well, it looks like I actually can, right? If this is 2 and this is -1, well then right here is going to be the x-axis. So if I wanted to, I could show that, right? Like, let's use black. All right, so the x-axis is actually right here. I'm going to make it in black. Okay, and I actually did a somewhat decent job with the line. That's the x-axis. The y-axis Well, that's going to be somewhere between 1 and -2. I've got 1, 2, 3, 4 values. Each of these is going to be what, 3/4. So the x-axis is going to be somewhere between these two. Okay, just if you want, you could plot that pretty accurately. I think I said x-axis, guys. I mean y-axis. Right? So what we're plotting, this point, right, that corresponds to the origin. All right, and if we go through our transformations, right, well, we vertically stretched it by a factor of 3. We shifted it down 1. Okay, well, 0, 0 stretched is still 0, right? But we moved it 1 down unit, or down 1 unit, excuse me. We moved it 4 to the right, and then compressed it. But again, if you're starting at 0, 0, you actually do this compression first, and then you do this second. So maybe that's overkill, but that's how you can make this graph. Hope the video was useful, and be in touch with any of your teachers if you have questions. All right, guys, take care, and we'll see you soon.